Welcome to the Explainer. So, how do you take a database that's handling millions of rows and make it flawlessly manage billions? Today, we are unpacking the secret weapon for absolutely massive database performance.
All right, let's kick things off with a pain point I'm sure many of us have felt. Your database grows, you hit a big milestone, say 80 million records, and then bam, everything just grinds to a halt. A query that used to feel instant now takes 30 seconds or more. And this isn't just a minor inconvenience, it's a performance bottleneck that can seriously cripple an application.
This visual here really frames the problem perfectly. The slow way, inserting one row at a time in a loop. I mean, it seems logical, but it's a huge performance trap. The fast way, on the other hand, using bulk operations, that's like a data superhighway. And that's a theme we're going to explore a lot today. So our roadmap for this is a classic divide and conquer strategy. We'll start by defining the billion-row problem. Then we'll dive straight into partitioning and how to supercharge queries. After that, we'll hit the bulk data superhighway, and finally, we'll put it all together and look at the results.
Okay, so let's start with the billion-row problem. What happens when your standard optimizations, all the usual tricks, just can't keep up anymore?
Our solution starts with that divide and conquer approach. And the very first pillar is partitioning. The best way to think about it is like turning a giant, chaotic, single-volume book into a series of well-organized chapters. Suddenly, finding anything becomes exponentially faster.
What we're essentially doing here is dividing one enormous table into smaller, logical pieces based on a specific key. And this is a real game changer because it lets the database completely ignore huge chunks of data that it knows, for a fact, are not relevant for the query you're running.
And the benefits? They are huge. Queries can be up to 85% faster, thanks to a process called partition pruning. It basically means the database is smart enough to ignore all the data it doesn't need. So instead of searching the entire library, your query goes directly to the right chapter on the right shelf. Plus, maintenance gets a whole lot faster too. Now, actually implementing this in SQL Server follows three main steps. First, the partition function sets the rules, like let's create a new partition for each year. Second, the partition scheme maps those virtual chapters to physical storage. And finally, you apply that whole scheme to a specific column in your table, like an order date. But, choosing the right strategy here is absolutely key. Range partitioning is perfect for data with a time dimension, like sales records. But what if there's no logical range in your data? Well, that's where hash partitioning comes in. It uses a hash function to evenly spread data across all your partitions based on a key like a user ID, which is great for preventing any single partition from becoming a bottleneck.
All right, on to our second pillar, supercharging queries. Once you have your chapters, you still need a really good table of contents to find things quickly within them. And that's exactly what indexing does for your brand new partitions. The most powerful concept here is something called the aligned index. All this means is that your table of contents, your index, is also split up by chapter. So the index for 2020 only contains entries for data from 2020. This makes it incredibly efficient.
And this alignment is so crucial for data management. It allows for unbelievably fast operations, like archiving old data. Instead of deleting millions of rows one by one, you can just switch out an entire partition instantly. We're talking about a process that can take seconds instead of hours. It's wild. Now for some pro tips to make your indexes absolutely fly. First, always use local indexes. That just means indexes that are partitioned in the exact same way as the table. Second, for your most common queries, you have to create covering indexes. These are special indexes that contain all the data a query needs, so the database doesn't even have to touch the main table. It is a massive performance win.
So that brings us to our final pillar, the bulk data superhighway. Because when you've got millions of new rows coming in every single day, you need a seriously efficient way to load them.
The secret to high-speed data loading is an operation that is minimally logged. See, normally, a database writes every single row insertion into a detailed transaction log, for safety. Minimal logging bypasses most of that, dramatically boosting speed by focusing on just allocating space instead of logging every single tiny change. Now, to unlock this kind of speed, you do have to set the right conditions. Things like using a specific database recovery model and temporarily locking the table during the import. You're essentially telling the database, hey, for this one operation, I need pure, unadulterated speed. So we've covered the theory, partitioning, aligned indexing, and bulk loading.
But what actually happens when you apply these techniques to a truly massive, real-world database? Let's check out the results.
The results are, well, they're absolutely staggering. Just look at this. On a table with 1.6 billion rows, a query that used to take nearly 7 minutes was cut down to just 2 seconds. That is the power of partition pruning in action. It's not just an improvement, it's a total transformation of what the system can actually do.
And hey, it's not just about saving time, it's about efficiency. Look at the disk I/O. The number of disk reads absolutely plummeted from over 500,000 down to just 7,500. This drastically reduces the load on your entire storage system, making the whole database healthier and way more responsive.
So, the key takeaway here is that these aren't just a few independent tricks. They are a complete architecture for scale that works together in synergy. Partitioning divides the problem, indexing speeds up the search within the smaller pieces, and bulk loading feeds the whole beast efficiently.
And that really just leaves us with one final thought. Your data is not going to stop growing. So the real question isn't whether your database is fast enough for today, it's whether your architecture is truly ready for tomorrow. Thanks for tuning in to The Explainer.